Hello friends, this is Combustion Numerical class second. In class first, we have already discussed type A and type B numerical. In type A, weight by weight, and type B, volume by volume. And now, today we will discuss type C. In case of numerical of type C, this is the interconvertible numericals in which we convert volume into mass and mass into volume. So we will take an example. This is a numerical. The percentage composition of sample fuel by weight is equal to 84.8% and hydrogen is 15.2%. So calculate number 1, the volume of air for the combustion, one kg of fuel, and second point, volume of air if 15% excess air is supplied. So in this numerical, we will calculate first weight of air and then convert into volume of air, and we will calculate 15% excess amount of air which will be utilized for combustion. So we solve. First, we will draw a table. In this table, first is number and then compound, and then amount, in gram, and now next reaction. We should also remember that reaction should be balanced, and next is required oxygen. So this is the structure of table. Now number 1 carbon and number second is hydrogen. Compound 84.8%, and this is 15.2%. Now we will convert this percentage value into grams. So amount of carbon is 848 grams and amount of hydrogen is 152 grams. Now balance reaction of combustion with carbon. Carbon react with oxygen and final product is CO2. And same hydrogen when react with oxygen and product is H2O, but is not balance reaction. So we will put half mole of O2 and this will be react with hydrogen and then final product is H2O. Now according to mole concept, 12 gram of carbon react with 32 gram of oxygen. So 848 grams of carbon will be react with how much amount of oxygen? So we write like this: 32 divided by 12 multiplied by 848 and final answer will be this 2261.33 grams. Now we will calculate amount of oxygen for hydrogen and same as how we will apply mole concept. 2 gram of hydrogen react with 16 gram of oxygen because this is the half mole of oxygen. So half mole of oxygen is 16 gram. One can say that 2 gram of hydrogen react with 16 gram of oxygen, then 152 grams of oxygen will be react with how much amount of oxygen? So we can write like this: 16 divided by 12 multiplied by 152. So the answer is 1216.0 gram. So this is the required oxygen amount. Now this is the required oxygen amount. Now we will calculate total amount of oxygen. So total amount of oxygen, total amount of oxygen is 3477.33 gram. So we will calculate point first, amount of air, amount of air, according to the important points which we have already discussed, that 23 parts of oxygen react with 100 parts of air. So if we have this amount of oxygen, this will react with how much amount of air? 100 divided by 23 and then 3477.33 gram. If we will solve, then final answer is 1 sorry, final answer will be 1511.8 grams, and we can convert this value in kg. So 15 so the final answer will be 15.12 kg. 15.12 kg. 15.12 kg. This is the amount of air for complete combustion of this fuel, but in this numerical we will convert this value into volume. So how we can able to convert? We know that 28.97 gram of air is equal to 22.4 liter of air at STP. This point we already discussed in important points of combustion. So 15.12 into 10 to the power 3 grams of air will be equal to 22.4 divided by 28.97 multiplied by 15.12 into 10 to the power 3. After solving, 11.69 into 10 to the power 3 liters will be the final answer. Now, point second, calculate the excess air, which is 15% excess air. So we can calculate like this. If normal amount of air is 100, so excess air is 115, because 15% excess, so 100 plus 15, 115. So if we have normal amount 11.69 into 10 to the power 3 liters, then excess air will be this 11.69 multiplied by 10 to the power 3, and then final answer is 13.44 into 10 to the power 3 liter. And we already discussed that 1000 liter, it means 1 meter cube. So 13.44 meter cube, this is our final answer. excess air 13.44 meter cube. This is the excess air amount. And this is the 15.12 kg. It is the required oxygen. This is the normal value of oxygen. And this is the final answer with excess air. Okay.